In this video, we will continue to practice our triangle congruence proofs. It's generally a good idea to go ahead and list the given and get that out of the way. So we are given that AC is congruent to AR. So we've listed that as a statement and the reason will be given. But we also want to mark that in the picture. So AC is congruent to AR. We are also given that angle L is congruent to angle S. So of course we will put the statement here and the reason will be given. But let's mark it in the picture. So angle L will be congruent to angle S. So we've run out of given and we don't have enough information to prove the triangles are congruent yet. So is there anything else in the picture that we can mark automatically? Now is a good time for me to mention that there are two things we can mark automatically. All right, things to mark automatically. One thing that you can mark automatically is a shared side. For example, if I have two triangles like this, the shared side will automatically be congruent for both triangles. And the other thing is vertical angles. So vertical angles are angles that are formed by intersecting lines like an X. So vertical angles are always congruent. So if you see vertical angles, you can mark those as well. So a shared side, vertical angles, mark those automatically. Looking at this problem, what can we mark automatically? I'm hoping that you can see that we have vertical angles right here. So we can mark those automatically. We need to write that as a statement in the proof. We need to say that this angle is congruent to the other angle. A common mistake that I see, some students will write this: angle A is congruent to angle A. That is wrong, unacceptable. These are two different angles. They have to have two different names. So we are going to have to use the three-letter name. So instead of calling this left angle angle A, we will call it angle CAL. So we can say that angle CAL is congruent to angle, and the angle on the right is angle RAS. These are vertical angles, so the reason is vertical angles are congruent. Now we have enough information to say that the triangles are congruent. So triangle LCA is congruent to triangle SRA. But why? So the reason is going to be one of those like side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. It's going to be one of those. So what do we have? As I look at this picture, I see that we have two angles and a side. So I'm just looking at one triangle at a time when I say that. So looking at this yellow triangle, I see that we have two angles and a side. So that means this is either going to be angle, angle, side, or it could be angle, side, angle. Both of these involve two angles and side. The difference is if the side is between the two angles, then it's going to be angle, side, angle. On the other hand, if the side is not between the two angles, that's when it's angle, angle, side. So is the side between these two angles? Well, no, it isn't, because here's one angle that is marked. Here's the other angle. This is the side that's between them. And that is not the side that's marked. So the marked side is not between the two angles. So that means this is angle, angle side. So you can just ignore this extra row. Let's look at problem number 2. So I see that angle B is congruent to angle D, statement, and the reason is given. Let's go ahead and mark that into the picture. Angle B is congruent to angle D. Now, this word bisect means to cut in half. We're cutting something in half. Focus on this right here, angle BAD. That is what is being cut in half, bisected. So angle BAD is this angle right here, from B to A to D. So this angle is being bisected. So if we cut this angle in half, then each side will be congruent. So this part will be congruent to this part. We need to go ahead and put that as a statement. We need to say that this angle is congruent to this angle. Both of these angles are at vertex A, but we can't just call them angle A. These are two different angles, so we have to use the 3-letter name. So for example, the first angle is angle BAC. So we can say angle BAC is congruent to angle, and then the other angle is DAC. Okay, I forgot to mention that, of course, we put this second given here in the as a statement in the proof, and of course the reason was given. So what is the reason that we will put right here for saying that these two angles are congruent? If you're ever wondering what the reason is, a good place to look for a hint is at the previous statement. Okay, look diagonally at the previous statement, and that will give you a clue. So notice that in the previous statement, we have an angle that is being bisected. All right, we have an angle that is being bisected. So guess what? The reason is going to be definition of angle bisector. I just rewrote it so it would all fit inside the box. So again, if you're wondering what the reason is going to be, look at the previous statement. If the previous statement says something about bisect, then the reason will be some kind of bisector. And in this case, it was an angle, so it's definition of angle bisector. Okay. This is not enough information to prove that the triangles are congruent. Is there something that we can mark automatically looking at the picture? So remember, the two things that we can mark automatically are shared side and vertical angles. Well, in this picture, there is a shared side right here. So we can mark this. When you mark a shared side, the statement is that side is congruent to itself. So AC is congruent to AC. This is the shared side. When you make this silly little statement that something is congruent to itself, that is called the reflexive property. Just memorize that. The reflexive property. So now we have enough information to prove that the triangles are congruent. Focus on one triangle at a time. So for example, look at the yellow triangle. So what do we have? I notice that we have 2 angles and a side. So that means this is either going to be angle, angle, side, or it's going to be angle, side, angle. It all depends on whether or not the side is between the 2 angles. If it is, that's angle, side, angle. If the side is not between the 2 angles, then it's angle, angle, side. So, is this marked side between the 2 angles? No. One marked angle is here, the other marked angle is here. This is the side that's between them, and that is not the side that's marked. So the marked side is not between the 2 angles. That makes this angle, angle, side. So my reason here will be angle, angle, side. We still need to complete the congruence statement. Triangle ABC is congruent to triangle what. The order of the letters matters. So first they have angle A. The yellow angle A corresponds to the white angle A. I can tell because they both have the double swoop. So the yellow A corresponds with white A. Next we have angle B. Yellow angle B corresponds with white angle D. So I'm going to put angle D next. I know they are corresponding because they both have the single swoop. So looking at the white triangle, so far I have AD. That just leaves angle C. So it will be triangle ADC. And just ignore this extra line because we're already done. Scrolling down to problem number 3. Let's get the given out of the way first. Angle NLM. So be careful because NLM is up here. So I've got this angle right here. And then that's congruent to angle LNO. Well, angle LNO is this angle right here. So that was given. We have another pair of congruent angles coming. So we have angle OLN is congruent to angle MNL. So angle OLN is this angle right here, OLN. So I'm going to mark that with a double swoop. And that is congruent to angle MNL. MNL is down here. Double swoop. Okay, that's it for the given. This is not enough information to prove that the triangles are congruent. Is there anything that we can mark automatically? Yes, the shared side. We can go ahead and mark the shared side. When you mark the shared side, you are saying that LN is congruent to itself. In other words, segment LN is congruent to segment LN. And when you make this silly little statement that something is congruent to itself, that is called the reflexive property. And you just have to memorize that. All right, now we have enough information to prove that the triangles are congruent. Let's start with the reason. I want to focus on one triangle at a time, so focus on this yellow triangle, please. What type of information do we have? I see that we have 2 angles and a side. So that means that this will either be angle, angle, side, or this will be angle, side, angle. It all depends on whether or not the side is between the two angles. If it is, then we have angle side angle. If the side is not between the two angles, then it's angle angle side. So is this marked side between the two angles? Yes, it is. One marked angle, I'm just looking at the yellow triangle. One marked angle is here. The other marked angle is here. This is the side that is between the two angles, and that is the side that is marked. So the marked angle is between the two sides. That makes this angle side angle. So that's my reason. And now we can make the congruence statement. Triangle LMN is congruent to triangle what? Well, the yellow angle L corresponds with white angle N. Notice that the yellow L has the double swoop, and the white angle N has the double swoop. So yellow L corresponds with white N, so N goes first. Next, we're talking about angle M. Actually, okay, so I'm sort of messing up. Let me start over. They've given us triangle LMN first. So that means this is the white triangle. Okay, so we have to look at the white triangle. And then our answer over here will be the yellow triangle. Okay, our answer will be the yellow triangle. So let me start over. So the white angle L is going to correspond with the yellow angle N. So that's why I'm going to put N first. Next, we're talking about angle M. The white angle M is going to correspond with the yellow angle O. Those are both blank, so I already know. And then last is N. The white angle N is the double swoop. That corresponds with the yellow angle L, which is the double swoop. So L goes last. And that's it. You can ignore the extra row. All right, I think this is the last one. We have given X is the midpoint of AB. And that is already written into the proof. And the reason, of course, is given because it is given. But this needs to lead directly to something congruent to something. How does that happen? Well, focus on the AB part. AB is right here. If X is the midpoint, that means that the left part is congruent to the right part. In other words, segment AX is congruent to segment XB. Now, for some reason, a lot of students get this reason wrong. Is this going to be the definition of midpoint, or is it going to be the definition of segment bisector? Right? Those are very similar concepts. But will this be definition of midpoint or definition of segment bisector? Well, for a hint, look at the previous statement. In the previous statement, you see the word midpoint. That tells you that this is going to be the definition of midpoint. If the previous statement mentions bisector, then you're going to have a definition of some kind of bisector. If the previous statement says midpoint, it's going to be the definition of midpoint. All right, moving on. Next, we see another given. Angle AXC and angle BXC are right angles. What are they talking about? Well, here's angle AXC and here's angle BXC. These two angles are right angles. We will show that with little boxes. So this is a right angle and this is a right angle. We're out of given. Oh wait, we need to write something into the proof based on the fact that these two are right angles. Okay, we need something that is congruent to something in order to do this proof. So, well, these are both right angles. That means they are both 90 degrees. That means these angles are both congruent. So, anytime you see that you have two right angles, you can immediately translate that into the first angle is congruent to the second angle. So I'm just looking right here and I see angle AXC is congruent to angle BXC. I can really just copy it straight from here. If you have two angles or right angles, those same two angles are congruent. And for the reason, you will simply say right angles are congruent. All right, I'm going to abbreviate it like this. All right, this means right angles are congruent. Okay, we still don't have enough information to prove that the triangles are congruent. Is there anything that I can mark automatically in this picture? Sure, you have the shared side right here. We can go ahead and mark that automatically. That needs to translate into a row, a statement, and a reason on my proof. So the shared side is CX. So you can say CX is congruent to CX. All right, that's how you handle a shared side. And when you have this silly statement that's saying something is congruent to itself, like of course, the reason is going to be the reflexive property. You need to memorize this. So we are now ready to say that one triangle is congruent to the other triangle. Let's do the reason first. Focus on one triangle at a time. Focus your eyes on the yellow triangle. What type of information do we have? Well, first of all, this is a right triangle. So anytime you have a right triangle, you should first ask yourself, is this hypotenuse leg? Well, the hypotenuse is right here, and it is unmarked. So this cannot be hypotenuse leg. So forget about that. So looking at this like any other triangle, I will see that we have two sides and an angle. That means this situation is either going to be side-side angle or side angle side. But guys, we have memorized at this point that side-side angle does not prove triangles are congruent. So if this turned out to be side-side angle, we'd be stuck because this would be useless. So you can bet it's going to be side angle side. But let's just follow through and see why it makes sense. Side angle side means that the angle is between the two sides. Is this purple angle between the two sides? Of course it is. Here's one side, here's the other side. See how they both meet at the purple angle? That's how you know that the angle is between the two sides. So this is in fact side angle side. Now we can make the congruence statement. Triangle XCA is congruent to triangle what? Let's be careful. Triangle XCA is the yellow triangle. All right, so they're giving us the yellow triangle. And we are being asked to fill in the white triangle. So keep that in the back of your mind. So first we have angle X. Yellow angle X corresponds to which white angle? Well, white angle x. They're both 90 degrees. So yellow angle x corresponds with white angle x. Next, we have angle C. Yellow angle C corresponds with white angle C. I can tell because yellow angle C is across from the single and white angle C is across from the single. So that only leaves white angle B. But it makes sense that yellow angle A will correspond with white angle B. And that's it. We can ignore the last row. We don't need it.